guys. I'm going to talk today about adding and subtracting decimals. When I ask you to pause during the video, make sure you're doing that and actually doing the problems, actually taking the notes as we go. That's how you're going to ensure the best growth for this grade level. Okay, so I would like you to do these problems on your own. Go ahead and pause the video. You better pause it. All right, so hopefully you have paused your video and you've done these problems. The correct answer is 43, so hopefully you got that one correct. Okay, write the inequality. This is a word that I'm going to use multiple times throughout the year. An inequality is your less than, greater than, or equal to symbol. You're going to learn two more later on this year. That is these two symbols. Okay, so which one is actually bigger? Well, this is how I've taught it in the past. They both share a 3. They both have a decimal. This has 1 digit. This has 1, 2, 3 digits. So what's after this 2? We'll learn that you can add as many zeros as you want after a decimal. So really, this is a 2. Here's the decimal. I could add 0 and 0. And this right here is 0.0 or 0.107, which we say that 107 thousandths, and this is 200 thousandths. So with the THS at the end. So which one's bigger? Well, if I'm not ignoring that right there, 200 is bigger than 107, so therefore this is greater than. I know a lot of you do like the alligator in the past. I do like this. This has 2 dots, and this one has 1 dot, so this one is bigger than the other. So how I read this as is 3 2/10 is greater than 3 107 thousandths. And there's your answer. You should have 2,604. All right, so hopefully you did those correctly. So in your notebook, go ahead and write adding and subtracting decimals. The goal of the day today is I can add and subtract decimals precisely, that means accurately, no errors, by checking my work. So we're going to make sure that our answers are reasonable when we do add those together. To add and subtract decimals, the biggest key here is that we're going to line up the decimals. We're going to add annex zeros as placeholders. Zeros are as placeholders, so they're not going to affect the solution here. And then we're going to check our work by using the inverse operation. So this is addition, the inverse would be subtraction. Good, got probably got that one right. So we want to make sure we do that. And also you can check your work by what we call, is my answer reasonable? So we're going to look at maybe like the whole numbers instead of all the numbers behind there. So if I look at number 1, I have 7 2/10 plus 9 5/10. It doesn't matter which one goes on top because it's addition. Addition does not matter, it's commutative. That means you can flip them around and order doesn't matter. So I'm going to go ahead and put the 7.2 plus 9.5. And remember I mentioned that the decimals have to be lined up. That means these two right here are in line with each other. So what you do is you just bring it straight down. So then you just add like you normally would. So think about it this way. It's like 72 and 95. The only difference is this would be 7, and then that would be 16, and I would have had 167 here.
Dante, could you come to the front office, please? Thank you.
And in the real world, that's called announcements. So I'm not going to stop and re-record. So this is the only difference between what you've done in the past and then with the decimal here. So how do I check if I'm right? All right, so what you could do is you can use subtraction, but I find that checking for reasonableness, like if my answer is reasonable, is by looking at the whole number in front of the decimal. This is 7, and this is 9. So ignoring anything behind there, 7 plus 9 is 16, and the answer that I got was 16 7/10. So guess what? My answer is reasonable. I did it correctly. Okay, let's look at the next one. All right, I have 1 and 34 hundredths, or think about like $1.34, and then I have 29. Well, where's that decimal at? Well, it's not 29 cents, it's $29. So really, if you see a whole number, there's a secret decimal that hides behind there. So I can add that decimal there. That's $29, not 29 cents. You don't want to go to the store and be like, oh, here's 29 cents when they really are giving you back, they should be giving you back $29. Big difference there. So the decimal does matter for place value. So let's go ahead and line these up. Again, it doesn't matter which one you put on top. If you want to put the one that has a greater value on top, that's fine. Or if you want to put the one with more digits, like I said, addition does not matter which one you put on top of the other number. I'm just going to put it in the order that I see it. 1.34, or we say that as 1 and 34 hundredths. And then I'm going to add by lining up my decimal. So my decimal for the 29 is behind here. And let's erase that because it's a little too close. 29. And then what I told you before, based on the directions, we're going to add annex zeros as placeholders. So now that I have these lined up, I bring it straight down, and then I can just add zeros. I could add as many zeros as my little heart desires, as long as I have a decimal. It's not going to change the value. Okay, so pretend these are not here. So I'm adding. So 4 plus 0 is 4. This is 3. This is 10. Carry the 1, and that's 3. So my answer is 30 and 34 hundredths. There's your answer. So let's check if it's reasonable. Let's just look at the whole number here. Ignore the decimal part. Look at the whole number. There's no decimal there, but we know those are technically secret zeros. So 29 and 1 makes 30. And therefore, my answer is reasonable. Okay, last but not least, I have one more example here. Go ahead and push this down because I know for some reason, it's because I'm recording, so it's a little different. We're going to do the same thing. We're going to line up the decimals. So right here and right here, again, doesn't matter. Say, I'm going to switch it up. I'm going to put this one on top now. 48.549 thousandths. Line up my decimals. Go ahead and put my 54.5. Lined up my decimals, bring my decimal down, and then I'm going to add my annex zeros, and then you do the same process. 9, 4, 10, carry the 1, 12, 13, carry the 1, and then that's 10. 103 and 49 thousandths is your answer. So how do I know if I got that correct? Let's do the same thing. Ignore the decimal. Ignore the decimal. I got 54 and 48. 54 and 48 is 102. Is that close to 102? Ignoring the decimals? Absolutely. Reasonable. You did it the right way. That's how you check to see if your answers are reasonable. Okay, same process for subtraction. Okay, make sure you're checking your work by checking for reasonableness, or you can do the inverse. Now, for subtraction, subtraction is not commutative. That means 2 minus 3 is not the same as 3 minus 2. Because $2 take away $3, you don't got $3 to give me. You owe me $1. Versus you have $3, you give me 2, therefore you still have $1 left over. That's why it's not commutative. So it does matter which one you put on top. We're going to put the first one. That's the what we're starting out with, and we're going to subtract that. Same rules apply. Line up your decimals, add annex zeros. So this would be 5.6 minus 3.5, or I should say 5 6/10, 3 5/10, and we're subtracting this time, so make sure you're paying attention to what symbol. And here, we're going to get a 1 and a 2. So 2 1/10, that's how you say it. Let's check if we did it right. Ignore, ignore. 5 minus 3 is 2. 2, and I got 2 1/10. That answer is reasonable. So we did a good job. Okay, next one. Again, it does matter when subtraction. We talked about where that secret decimal's at. This decimal's right behind here. Remember, it's $97, not 97 cents. Big difference. Okay, so you can do this. So this is actually 97. So that goes on top. Put your decimal there. Line up your decimals. We're going to show subtraction. I have 16 98 hundredths, so 16.98. So again, just like before, I'm allowed to add annex zeros. It doesn't matter where you do it, so we can add it on the top this time. Now, number one mistake I see all the time as kids, right? 98 right here. Just like that kid did in our warm-up, they forgot to borrow, so don't you forget to borrow. So you make this a 10, you make this a 9. But since you borrowed from that, you're gonna make this a 6. Okay, 9 minus 1 is 8, 0, 0, 2. So I got 80 and 2/10. Now, if you're not sure, especially with your subtraction, are you doing your subtraction correctly? I have a lot of kids struggle with borrowing because they don't remember the rules, they don't remember the process on how you're actually getting your answers. So I would suggest that you can obviously check for reasonableness first. So I'm going to do 97 minus, ignore the decimals, 16. So I should get 81. That's close to 81, so we did well. However, I don't know, let's say you don't know if you borrowed correctly. Okay, so then all you do is you take these two and add them. Again, it doesn't matter which one you put on top because it's addition, because it's commutative. So let me just check to see if I borrowed correctly. We're all guilty of it. Sometimes, like I said, I make mistakes. And then this is a 9, and then I'm bringing down my decimal. 97 is the same, 97 is the same as 97.00000000. I don't care. I can have no zeros. I can have 1 0 as long as I have my decimal there. Okay, last but not least, let's look at one more, and then I'm going to go ahead and have you practice on your own. So you're going to do 58 and 6/10. Remember, the first one when we are subtracting has to go on top. Minus 28.72. Make sure you're lining up your decimals. Paying attention that we are subtracting still. Go ahead and add in your annex 0. All right. I'm going to go ahead and start borrowing because remember, we need to borrow. I can't take, this from that, so I need to borrow. So I make this a 10, this a 5. Well, then this doesn't work. So I make this a 15 and make this a 7. Well, then this doesn't work. So then I make this a 17 and I take 1 from there, and that's a 4. Now I'm good to go. 10 minus 2 is 8, 8, 9, and then 2. So I got 29 and 88 hundredths. So let's see if we were right. I'm going to check 2 different ways. Ignore this, ignore this. Let's subtract. 58 minus 28 puts me at 30. That is very close to 30. Think about it as $29.88. That's close to 30. So we did that correct. But I want to make sure my borrowing is correct, like me actually doing my subtraction. So I showed you before, add these together. I'm going to go ahead and do it right over here. So 28 and 72 hundredths plus 29 and 88 hundredths. I'm checking my work. Let's see, that's 15, 16, 17, 18, and a 5. Bring down my decimal, 58 and 6/10. This is 58 and 6/10. Remember, like I mentioned to you, I can add as many zeros as I want behind here. So we did it correct. All right, so typically at this point in the video, I would then have you practice these on your own. So I would put up a timer here, but since you're not here, this is the time where you would be going up to my whiteboards around the room for you to practice. So since we're doing a virtual, I'd like you to pause your video now, and you better pause it. Okay, so if you don't have any other questions, hopefully you did not do a Miss Edwards over here, because like I said, I'm not perfect. I make mistakes, especially with a lot of pressure for me to record myself. But now we're just going to add the word problem focus. All right, question number 1 says, the table shows the top 3 finishers in barrel racing. Okay, how much faster did Nicholas go than Sancho? Now remember, when we're talking about time, the lower the number, the faster those people are going. So you want to look at, in this case, we're going to look at Nicholas and Sancho. So Nick won by how much? How much faster? How much faster is we're trying to find the difference between them. What is the difference between those two? So we're going to use subtraction. Now you're going to go, okay, which one should go on top? Well, if we do like we did before, this is like 14 and this is 16. So we can't have a negative, right? So we need to put the 16 and 4/10 minus, let me go and erase this so we can look back at the original, minus, by lining up the decimals, 14 and 67 hundredths. And since I am subtracting, don't forget to borrow. So this is a 10, a 3. That doesn't work, so then I need to borrow from this and make that a 13. Everything's good now. So I have 1 and 73/100, and this is the seconds. This is the difference between their speeds here. There you go. All right, so that is how we look for those keywords to indicate what operation we're using. Addition, subtraction, multiplication, or division. But since we're in addition or subtraction, we just got to know which one it is here. What is the time for the writer? Time for the writers all together. So the keyword here is all together. So putting them all together, that indicates that we are going to add. Again, with addition, it doesn't matter which one I put in front. First, second, whatever. I'm going to do 2 at a time. I find that easier to do 2 at a time instead of trying to add all 3 down at the same time. It doesn't matter, but the key part here is that you remember that 15 has a decimal after that, and it's like $15, and I'm going to add a 0 here. So once I do that, everything is perfectly lined up. So 14 plus 15, so 14 and 67/100. And then I'm going to take this answer that I got and then add Sancho's time by lining up the decimals. I already added an annex 0. And so that's 7, carry the 1, 16, and there we go. And this is what they have all together. So we're still under a minute for all of their times there. Okay. All right, so next question here. The table shows the times of different swimmers at a recent Olympics. So it took Magnuson, sure we'll go with that, 0.3 of a second longer to finish than Trickett. What was Manguson's time? So we know that we do know Trickett's time. And it says that this person right here, we want to know their time, was 0.3 of a second longer. So think about it. Am I going to add or subtract there? Well, longer means it's going to be, it's going to take them longer to do that. So you should have said that you're going to add that to Trickett's time. So here we go. It's addition, doesn't matter. So I have 56 and 73/100 plus longer. I'm going to put 0.3, which is 0.3, but I have to make sure I line up the decimals. Now, kids in the past had asked, do I have to put a 0 here? No, you do not. That is optional. If you like it, fine. It's not going to change the answer. It's still 0.3. Okay, so then add it now. That's a 3, 10, 7, 5. Bring down your decimal, and there you go. So what was Mangus's time, or Magnus? It was 57 3/100 seconds, right? Because it is in seconds, so we can use an S for seconds. In 2 months, Micah spent a total of $305.43 on groceries. That's kind of something we want to keep in mind here. She spent this $178 in the first month. How much did she spend in the second month? So this tells us what she spent in the first month. We want to know what she spent together. But it says in the 2 months she spent a total of. So whatever she spent in the first, total means to do addition, right? So those 2 months put together is addition. Whatever she had in the first month plus whatever she had in the second month is equaling our total. So to understand which operation to use, just because it says total in the problem does not mean you are going to use addition. So you need to be careful on what the question is asking you. I want to know just one of the months. I already know what the total is. She spent a total of $305.43. In the first month, she spent $178, which I know the decimal would be here. And so if it rang up at the register, it would look like that. I want to know what they spent on the second month. Would you add those together? You're going to spend $400 some in the second month? That doesn't make any sense. What you're going to do is to find what the missing amount is, you're going to use subtraction, okay? So which number goes on top? Well, this is the part of it, you gotta think about it logically. Am I going to take $178 and subtract $305, or am I going to take $305 and subtract it from subtract $178 from that? It is the one that, in this case, I'm taking the total and taking away one of the months. So we have here, I'm gonna go ahead and move this out of the way. We have then, I'm gonna take $305.43 minus the money I spent in the first month. And I don't have to borrow here because I am taking 3 minus 0 and 4 minus 0. I do have to borrow, oopsies, it's 15. Make it a 9 and make this a 2. Okay, so 15 minus that is 7, 2, and 1. Now let's see if my answer is reasonable. So if I take $305 minus, remember I'm ignoring the 43 cents, minus this, I should get 167 about, I mean 127, excuse me. And I'm at 127.43. Now, I don't know for sure. I want to make sure that we're working on precision, being precise, being exact. Let me make sure I did my math right. $178 plus the answer that I got, which is what I'm would put right here. Let's double check. Doesn't take very long if you know your your addition facts. $305.43. So I did it right. So what's the answer to the question now? So it says, how much did she spend in the second month? She spent $127.43. That is the answer there. Okay? So just because a problem says the word total, and you're like, oh, total means add. Don't stop there. You need to read what the question is asking you. Okay, last but not least, second part here. How much more did Micah spend between the first and second, that's a typo, months? Okay, between them, how much more? So we want to know like the difference between those. Difference means to subtract. I want to know the difference between this one here and this one here. Okay, between the first and the second month. Now I don't want to have a negative value. So I want to put the one that has, you know, that is a larger or greater value. So I would take $178 and subtract the second month and see what I get. Now here we have to be careful. We need to borrow. Okay, so 5, 0, bring down your decimal, 5, 7. So there's a difference of, this is what I think it is, but I want to make sure that I'm correct, $50.57. Now, let's see if my answer is reasonable. If I take, ignoring this part right here, if I take 178 and subtract 127, that's $51. That's close to $51. So far, so good now, but since I subtract, especially if you're a little sketchy on your subtraction, you want to go back and add those together. So let's go ahead and do it here. I'm just going to go ahead, instead of rewriting, I'm going to do it right here. So it'd be 10, 10, 8, 7, 1. There it is. So I am correct. There you go. A hat costs $10. So I know that this hat costs $10 and a t-shirt costs $14.20. I'm a picture person, so if you're a visual person, there you go, you get an idea of that. How much change will you receive if you pay for both items with a $50 bill? So this is the correct answer. So how much change will I get back is $25.80. If you want to push yourself a little bit further, I have these two challenge problems that I'd like you to do. These are great test questions, great air questions. So I'm gonna go ahead, if you would like to continue, go ahead and pause the video. If not, go ahead and work on your practice assessment. You should have gotten these similar answers. So now you may go ahead, either come back onto Zoom, ask some questions if you have any, or go ahead and start your practice assessment. Have a good one.